everybody. Let's get started. So this is my first stream on Twitch. Uh, I used to do lots of like recorded, I guess you would call them vlogs or whatever you want to do, but first time actually streaming stuff, so it'll be a little bit different for me. I suppose tonight, I didn't have particularly anything specific in mind, but maybe let's take a look at some of the projects that I actually do work on. So this is my GitHub page. I'm eSatterwhite on GitHub. It's pretty easy to find. I have these pinned repositories here that are the things I typically work on, and I think tonight probably going to take a look in Skyring. Skyring is the one I probably work on the most as of late. It's a node project that how would you put it? It's distributed timer. So I work in distributed systems of one flavor or another, and always comes up the situation where you want to use set timeout for various reasons in the JavaScript, right? You need to delay action of something. You may need to cancel it. You may need to reset it. Variety of different reasons, but you can't really rely on that in a distributed system, stateless servers, because timers require some amount of state. And if your process crashes, that kind of goes away and you're up a creek. But Skyring aims to solve that problem, and it kind of gives you a simple REST API to manage timers in a distributed way and not have to worry about system restarts or crashes or anything of that nature. And I suppose in previous places of employment, the problem tends to arise. Well, let's say I worked in telephony for a while, right? I worked at ShoreTel, and we worked on phone systems for call centers, basically telemarketing. And they had this really interesting feature where after a telemarketer had ended a call, they wanted to keep them dialing. So if when they hung up, they didn't want them to sit around and not be calling people. So our system had to effectively allow for a configurable amount of time that would automatically start dialing for them. And in JavaScript, that sounds like set timeout, right? If you just set timeout, make phone call of 10 seconds, and if they didn't start, it will start for them. But in clustered servers, stateless servers, that becomes a little bit of a problem, right? You can't really rely on set timeout. And I used to work on a different project called ZMQ Bus, which is what I used to use to kind of solve that problem before. And maybe we can find it. Bus? Yeah. So this was a project that I worked on with this guy for a little bit, and it kind of solves that problem, but it's more of a pub sub sort of a situation. So it was kind of hard to scale things as you would send messages out. Every server in that cluster would receive the message. So in the context of a timer, right, you'd set a timer. Every server in the cluster would set a timer, and when you had to cancel it, every server in the cluster would have to cancel it before one of them executed. It was like a designed race condition, and it was really hard to manage. So I kind of use that as a basis for building Skyring. And Skyring takes a slightly different approach. It uses consistent hash ring of servers, right? It sits on top of a project from Uber called Ringpop. And it's basically gossip protocol for a bunch of servers that know about each other as they come online. They kind of tell each other about the other nodes in the system, and they can find each other. And it works out pretty well. They haven't really worked on it for very much lately. I have a couple of PRs on it because there were a couple of bugs in there that they haven't merged yet. But Ringpop's really nice. It's kind of it's chatty, as you might imagine. It's a gossip protocol, but as servers come and go, they let each other know about them, and it solves the problem of timers really well because you can just use set timeout in JavaScript. But I think we're going to work on this tonight a little bit. There's a couple of things I've been doing here. the thing I've been working on lately for this is trying to get some sort of insight into the project or the servers as they're running. Um, so like getting an idea of when they join, when they leave, when timers get set, when they get removed, having like a single point of contact for all that stuff would be really helpful. And I'm kind of stealing the idea from a project called Celery. It's written in Python, and it's used for managing distributed tasks in large systems. It's a Django project. They have a interesting monitoring tool called Celery EV, and I'm not even sure they support it anymore. But it was like a neat little ncurses app. Find it. To correct my yeah. So it was a little it was a little Celery app, or sorry, a little ncurses app that you could basically connect to any server that was aware of the cluster and SSH in and pull up a little ncurses app. You didn't need a fancy web browser UI or anything like that. It just kind of told you what was going on, and you can kind of drill down into events as they were happening. It would show you the data payload and all that kind of stuff. So I've been kind of tinkering with ways on how to do that. So let's take a stab in some code here. So Skyring's it's a pretty simple JavaScript app, right? It's written in Node. There's not a whole lot going on in here. Each one kind of knows about its own stuff, and that's about as far as it goes. But it does use a slightly modified HTTP server that is very similar to the one that we use at my place of employment. And it is very fast. We're lucky enough to have a couple of Node core contributors on our team, and they write some really insane, very performant and very efficient stuff. And the HTTP server is one of them. And so there's not a whole lot to it. Obviously, as you can see here in this little server directory, there's about 5 files in here, and that makes up the entirety of the HTTP server. And it's very simplistic. All it really does is parse the URL, map it to an HTTP function, and call your handler. There is a middleware stack in there, but it is used for very little. Most of this is direct mapping of like a configuration to a server, to a route URL, and that is all it really does. That's part of the reason it makes it pretty fast. But one of the things that a lot of HTTP servers out in the Node world do is they will tack properties onto the request object. And Express is pretty well known for doing this, where they just request dot whatever, and they'll tack tons of stuff on there, and that will cause the actual request object to go into dictionary mode, which makes it slow, really slow, for accessing and rewriting properties on there. And so one of the things that this thing does is it makes one object, one property on the request, and it just sticks everything in there, which keeps it out of the dictionary mode. So like here on the side, you can see there's 3 routes on this application. There's a put, post, and delete, which is the routes that actually create a timer on the server. And they're pretty simplistic. So if you look at here's one to create a timer, the entirety of the function is here. That's all of it. And there's 2 pieces of middleware in here. There's a proxy and a validate, and I'll explain what that is in a couple of seconds. But the validator just basically makes sure that the request has the right kind of data. Otherwise, it'll return a 400, and that's about it. The proxy is where stuff starts to get really interesting. So as I was talking about before, there's this little project called RingPop, and all it really does is it aligns servers together. And when we get a request in the server, if we've determined that the server is not responsible for handling that particular timer, it will immediately proxy it to the right one. And so all it really is doing in here is there's this little bit in here for is it responsible? So you see that little function in there. There's a handle or proxy function. And that's just calling a little function on the yeah, on the ring pop instance internally, and it returns true or false. And that's basically just using the ID, which is a UID, and it's hashing it and it's sending it along. That's really all this really does. And this little piece of middleware here is a timer ID, which basically just checks for a header, and if it's not there, it will assign it. Again, really simple. So where it gets the nuts and bolts of this entire system is kind of laid out in this timers module, and it's doing most of the work. It's kind of a wrapper around set timeout. It will keep the storage up to date with the timers that are currently active or have lapsed, or as the ring is rebalancing or distributing timers throughout the ring. It's capturing them, checking them to see if we have a reference to it. If not, it'll ignore it and set it or remove it appropriately. But this is kind of where the I started adding events around this in the system for handling introspection. And so yeah, so if we take a look, you'll see in here that there's a bunch of dispatches for a Skyring events key, and it's really just kind of stringifying a bunch of data and sending it over the wire. Right now, it's sending it over a NATS connection. NATS is kind of the safety valve for redistributing information when parts of the system, if it crashes unexpectedly or goes down, it has to effectively remove itself from the node. So it will use NATS because it's no longer part of the ring pop cluster. So it's kind of just sending stuff out over a separate channel that is not able to accept work other than, in this situation, these kind of events. And so that's kind of where I've been headed. You'll kind of see this these event status created, and there's an event status exec over here when we execute a function. These are pretty self-explanatory. They're all kind of just inlined up here. So kind of looking for, so we've got, actually I might have done most of this already. We have a shutdown, there's a success, there's not really a join event. I am kind of interested in when things join, so I might a join event. It's been a while since I've been in this chunk of code, so let's take a look at where this is actually happening. So there is this. The server has a node module, which is a wrapper around ringpop and T-channel, which is how ringpop communicates with itself. Kind of a multiplexing library. And there's a join function in here that basically starts the entire process of adding rings or adding nodes to our cluster. And when they connect and are active, they will dispatch this ring change event, and that lets the rest of the that's letting this particular node that it has been accepted and something has been rebalanced. So this does not actually have connection to NAT, so we won't be able to dispatch a join event from here, but we do have a NATS connection in the main server, which is kind of the wrapper around our NATS instance and our timers and all that stuff. So in here, yeah, so here's where we're kind of capturing the ring change event, and here's where we're capturing the bootstrap event that lets us know that we've actually connected. So I'll bet we can probably just do this here. We'll add an event handler for join, and I don't find it. Well, maybe we don't want to do that, because this will be caught by all of the other servers. So let's not kind of do that right now. suppose what we could take a look at, I did see a few documentation bugs in here, which is also important. Let's take a look at, let's see what events we do actually get out of here. Let's start one. Yeah. We can take a look at, I do samples directory that has, yeah, there it is. Blog.test. So this is the file I was using. Don't have syntax highlighting on this guy. Set it to JavaScript. There we go. So I was kind of using this as a way to test the events, and it was going okay. Like it functions, but there isn't really a UI for this just yet. It's just kind of I really made a release that introduced how this might work. So it just kind of sends the events, and this particular little test file will catch them and write them out. And so you can see that this comes over a NATS channel, and that's all it's really doing is just kind of spitting it out to the console right now. But let's see if we can remember if this works or not. Maybe it does. Let's go into our Skyrim directory, and we can start one. So start this on, we'll do localhost 4456, and we'll run the C channel on that same port, and I'm gonna run. I think I would like to replace the debug module. It's not what I mean, it's fine for local debugging, but right now there isn't a way to like log. As I imagine, most things will want to capture log information off of the server, but right now it just spits everything out to debug, which is writing it to standard error, and it's not a really great place for that kind of stuff. I need to do a kind of a refactor a lot of that logging stuff to make sure that debug stuff is actually used by debug, and things that are important is actually logged by some sort of a structured log. And but time. So let's take a look at. There we go. And if we do, let's take a look at test. Yeah. All right, so that catches it. Port equals 345. Yeah, so it's a fairly decent kind of a way of demonstrating that how this might work. You'll see over here when the server started, we kind of got a recovery event, and then a ready event that kind of says the server is up and ready to receive requests. We can basically just curl I have this little sample file here for sending information, and we're just going to send it to server running on port 3000 /timer to create a new one. And so we created one. That's good. See down here we got our created event. We didn't get a failure event. We should have. So look what happened. I do have also node a sample server to accept the timer. All right, try that again. We'll issue another uh, Throw request at, oh, let's make sure our, so yeah. This is basically like the payload that is required to create a timer. There's a timeout property that would indicate this is how long before we actually execute it. And it just basically is it's passing that right to set timeout. Uh, Data payload is just a string of data, and that can be uh, literally anything you want it to be. It could be JSON data, it could be XML data, it could be a HTML page, it could be plain text, doesn't really matter. The callback describes how we actually deliver the timer in here. So there's this transport, which is HTTP in this situation. So basically, Skyring operates like a webhook or a postback, however you would like to describe that. And the method describes the HTTP method that it's going to use to deliver the payload. And this describes, the URI we're going to send this request to. So when you set a timer, you basically just get an HTTP request back in this situation. But sure, let's make sure the IP address on this is right. Oh, we did get it back. It failed. Perfect. It worked. So you got a fail event because there wasn't a server on the other end to receive that request. This particular IP address is 10.2.15. So I'm going to reset this IP address here to be, that should work. So here we can node. That is just, this little server just echoes a number indicating that a request was received. Pretty much, there's not a whole lot going on in there. Curl this again. We can post it, and we can set the data to the payload txt. I guess this timer. Set the timer. Let's make sure that it gets executed. And it did. So that actually kind of works. So there's this. You'll see here now we have a success because the server was actually setting it, and up here there's this one, because we had one request post back, and when we close it we get a shutdown event. That's kind of what we're looking for. Do we get one when there's a recover? Perfect. That's kind of what I want. I guess my next piece of business in here would be to actually try to put together a UI for it. I was looking into a couple of different libraries. I was looking at Blest, which is a JavaScript library, and I had kind of something working for but the library, hasn't been touched in a while. It's got some bugs that was kind of preventing me from getting the job done, really. This is a JavaScript implementation of basically curses, which is kind of what I'm after, but the way that it redraws kind of blows away previous data. And so like maintaining a list of active servers and events and an event stream doesn't seem like it's possible at this point. I didn't really dig too much into the code for this, and this hasn't been touched in a couple of years. So I'm not sure I'll be able to use this one, but it has pointed out that there's a analogous project in Go, and lets you do some rather interesting stuff. I haven't played around with it too much, but I did. I know very little Go at this point, so I didn't get too far with it. But I have a start on a project for this, so I think I might go that way. Maybe we can do that next time. Watch me fumble around with Go, because I know not a whole lot. I mean, I'm familiar with some of the syntax and the language, but it's not something I do a whole lot in the day-to-day business. So we might do that, but that's kind of what I'm going for here is to kind of replicate this kind of feature for the project so that you can get a bit of insight into what's going on. So I think um, I think yeah. The other thing that was really kind of bugging me in here was that there's a flaky test, and it's kind of hard to figure out why it's flaky. If you run the test individually, it seems to always work. In CI, it's kind of sporadic, and it's the server one. The server one's kind of it's basically the test that fails in here is there's a rebalance test, and so this is basically testing that when a server leaves, any pending timers get redistributed and executed as follows. So um, really what it's doing is this test is setting up three server instances, letting them all connect and find each other, and then sets like 50 timers or so, and then kills one of them. And we should still get 50 timers back. And that's also it sounds like it should work, and in most situations it does. Like here, if we run this, host needs to be local host, and node env needs to be test, and if we do node test unit server, so it sets like 50 timers and good. Yep. So I mean, I'm not really sure what to do about that. In CI, this tends to be the flaky bit. It tends to not always get them, but I can't get the test to fail locally, and I've not seen that behavior when running the servers, in a real world situation. But I'm not entirely sure what goes on there, and I think it might have something to do with like a race condition between a server connecting to NATs potentially, but as far as I can, the way it's written is that it won't register as ready, and it won't call the callback to the listen function until NATS has been it's connected to NATS and the timers are ready, the database is loaded, and any recovery period has finished. So it's a little bit hard to track down. I'm not too sure what to do there, but that is something I would like to fix. I just haven't really identified it, and hasn't. Oh, yeah, so this one stopped. Apparently obvious as to why. Uh, huh. All right, so there's a flaky test in here. Let's maybe if we this down a notch to not be 50 or 100, we can narrow it down a little bit. Um, so 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 this one is setting a timer for this request array, which is just being an empty array with 50 slots, so that it just runs over them all. So there's this an array of 50 things that we just kind of run over and use it to set a timer. It's down to 5. We should only get still. Oh. Hmm. So we just got an error. Database is not open. That's coming from LevelDB, which is what the database that's used to kind of keep track of data. And that would indicate that the test actually started before the database was open. For one, let's take a look. In libtimer, out of here. I'm on the other side. In libtimer on line 201. So this is come from. This is the create function. This must come from. Oh man, why would you even get there? Why would that even get there? Let's look at the stack trace. Quick. Timer create timer. Get from a route handler. So that was actually coming from the request. Interesting. So that might be part of it. Let's take a look. Constructor, because that's the thing that actually spins up the database. The callbacks. The callback. Yeah, I mean, this is waiting for storage backend ready, then calls the callback. This doesn't even, yeah, this doesn't even acknowledge that the database is open until we have, until after we have received a ready event from Nats. That should never happen. Maybe if we start this log thing, it does that. That works. Maybe that was a fluke. This is not open. So the oh man, that's weird. This is uh so this I wonder if LevelDB has like an error event. Uh so mm, oh. Yeah, so I even left a comment for myself here. What happens if LevelDB fails here? This is in the create 201, so that does error out. It doesn't seem to test finish, but maybe it's just not done opening. I wonder why it would give a callback. Oh, oh, yeah. I'll bet you this is because let's take a look at the test again. So, the storage option is using by default uses memdown. So I'll bet you there's something weird with memdown calling a callback before it's actually registered that it's been completely opened, and I'll bet you that's what that is. I'll bet you if we switch this test to use not memdown as a backend for LevelDB, this might actually not throw that error. But let's take a look at the server one. These servers are using So these are using just randomly created crypto. So you need to, let's try switching this back into level down, and maybe this will, I wonder if there's like a weird bug in mem that it's calling the callback before it's actually open, and that would be awful. Not looking forward to having to track that down. Let's, yep, one succeed. That also succeeds. Also succeed. Let's take a look at where this error is coming from. 178. Batch error. If the database is not opening and is not open, and we dispatch this error, that really sounds like that should not be the case, because we are very much calling, we're very much opening it, and we are waiting for it to actually acknowledge that it in fact opened. Constructor. So this is creating options for level DB. We're kicking them out to debug, storing a generated ID, or making it with node ID. Just creates an instance. Let's take a look. I wonder if there's a look at level up for a sec. Node level. Let's take a look and see if this thing takes a callback. I'll bet you I'm missing an error. And it's not opening all the way. Constructor for this. This does optionally callback. But this says if you don't pass it the callback, it's going to throw. That it did not do. Here. See a throw. Oh, there it is. So this will throw if it does not actually error. I mean, if it does not actually open, which would indicate that it is, and it runs us on the next tick, so like it is open. So take a look at this. DB open takes a callback. Doesn't say it takes. That's unfortunate. All right, well, let's take a look at the code for this. Level up, the callback. Oh, we'll just take an error. We're going to take a callback for this. Already got a bracket. Unable to open level up storage, and just dump the error in our styring store. So save that. We can close this. Run this test again, but I'm going to start it with debug, skyring, should tell us where things are going wrong. So they all opened. We used level down. All got a random look for the database and where again, same thing. No error. Run again. No error. That time we did. Happened on all 3 of them. But they were already open. I wonder if there's like a what is going on? That is so we got we got they all indicated that they were open, and then like on the next tick it says it's not open. That doesn't make a sense. That doesn't make sense. What are you doing, Level DB? What are you doing? Why would you do that? Excuse me. Let's take a look at what's going on in this space. This is probably going to be really noisy. Two, 3. Now you're going to throw on. If you're going to say I had to put a console log to make this thing pass, I'm going to be very confused. That is so weird. Die. Die. That doesn't make sense. Let's line out of here and see if it can. If there's like a weird timing issue with the. That's really weird. Let's go back and add a log inside of the error handler for level DB, and that race conditions are the worst. Nope. That did. Ooh, here we go. Database is not open. Doesn't have this little. I wonder if doesn't have this little. That's interesting because this 70 looking for if opening opening function status isn't open. The stat codec E status is new. Ooh, status is what you called it. What are you doing? What are you doing? That I don't like that. That's really troublesome. You'd think somebody would have encountered this. Level DB's used pretty heavily by a lot of people. Why would you mark yourself as new but not mark yourself as open? Where do you mark yourself as new? New. So the new, this is in the constructor. So, so this thing is marking itself as new in the constructor, opening a database, calling the callback from the open call, and not marking itself as open or throwing an error. What? Oh, okay. So here's the open function, and the first thing it does, there's like no. So weird. So I mean, like if it's already open, it just skips it. But if it's opening, it just skips it again. But it emits this opening event, and the first thing it really does is mark itself as opening, and then it opens the internal database. There was no error because it gave me error that database is not open, and it emits an open, marks it. Fucking why is oh level DB? What are you doing? What's I'm gonna add like an event handler on the storage thing for like opening and open and seeing this act. It's marked as open. So there's opening event and an open event. So we can well, let's give it a shot. So somewhere in here, storage is to this storage name this .knode, which is where I store the ID for this particular instance of stuff. Just do opening. It's for open. Yep. All right. So if all the databases are actually open, this should in fact open all those callbacks with an event for it, and everything's fine. On these tests again. Huh. It did. 1, 2, 3. There's 3 of them. Oh man. So we did get 3 open events from the database. Then we get an error saying that the database is not open. That seems right. Oh, get an opening event. Could we? Would you get an open event and not an open? Seems like you should. It looks like you should. Right? Wouldn't you? Well, that's interesting. What? Look at pump out what this. This should be status. Not getting an opening of it. Interesting. Open. This should be, um, run it again, see if we can get it to toss an error at us. And they're all marked as open. So, all right. All right, so we're getting display error. What do you do? Do I get an error event for you? It's like a request. Fetch errors. You fill comes from. All right. This dispatch error doesn't. Oh, all right. So this will actually error if there is not our take a look at stack trace 251. So, all right. So the problem is level DB is telling us that it is open and something is getting caught in a non-open state, which seems really weird because the servers won't actually start until we get confirmation that the database is open and we have a connection valid. Uh, Trying to put a key. It does send a callback. It's coming from timers. This guy coming from our write function. That came from a post call. And it came from post timer and hit timers at line 209, which is where we do storage output. Really weird. Do so log the node ID on this node. I want to make sure that for whatever reason don't have like a weird stray server getting caught somewhere that didn't shut down properly, like picking up a message from NATs and it's not supposed to. That would explain why the test sometimes fails and sometimes doesn't. If there's like a random server just hanging around, not being cleaned up, and it's just really a timing issue. So they all fail. This one, this says this is the node of EF9. And we certainly got notification from LevelDB that this EF9 database was open. Then it's immediately telling me that it's not open. That sounds not good. Happened 3 times. I got all this. Fine. Why would you do LevelDB? All right. Okay. We got another one. This time 9, 6. Says it's open. Database is not open. It's closing. Oh, that's what it is. We're closing this thing before. We're closing it before all of the work is done. That makes a bit of sense. All right, so that we can fix on our side. Let's do what we were doing in here because it's not really needed anymore. Oh, look at our test again. So this, when does this close? It closes when test is over. Probably got some late balance work in here. Then this one. Let's do comment. Uh, and the server, so symbol. Put an ID property on this server so we can just figure out which one's actually closing. That's not a big deal. We can clean that up later. This is just like race condition between a server closing and the test ending, because TAP has a couple of really interesting ways of determining when your test actually is over. This one has a plan on it, so that's also, there's just like a proxy happening before we've actually handled it, and LevelDB does not like that at all. So we can go into our server code, and there I can add an ID function on here so that we can dump this out for this test content. Or has a prop on it. They're dynamically generated, so you can't really know. And I've got it hidden behind a symbol, so I can't immediately get it off of this thing either. Put it in. Yeah, it's stored in this knode symbol. I don't think I function for this in here. Really don't want people to mess with it, but it's just for purposes. Return this node back over here. Free D. Yeah, so we're just gonna dump that out when we're closing that server, so I can get a pretty good idea of which one culprit being closed. Here somewhere. Arrival loss. Should error. And requests. Sure. Let's take. Oh, is it heaven? Think. I think we're gonna have to like delay the closing of this because the requests are still in flight when we're trying to close. So kind of makes sense why sometimes. So uh, does close. Or a server takes a callback, we can just do it in the callback of the server. Do an extra, like a pass, and set an additional test plan that close does take a call. Up to 7. So we'll expect that extra pass assertion to happen before we actually go and close the database. I'll bet you we won't get a failure on these guys. Look better. This looks better. Flaky test solved, I think. Alright, well that makes me feel better. It wasn't level DB's fault, it was just my dumb fault. That happens. Alright, so let's just clean this guy up a little bit. Well, I mean, that's fine. Don't that. Rid of this debugging comment. I suppose we could those events in there. We could debug those. I kind of like having those opening. I don't know why we weren't getting this. We weren't getting the opening event from level DB. We only got the open events. That's kind of because there is an opening event that should happen at least once, and then we get our open and ready. Oh, that's interesting. You get the open event after the callback. I don't know if I like that. I think that should be the other way around. I think the event should happen before the call. I guess it doesn't really matter in this situation. It's all happening on the same tick, but I generally expect the events to happen before the callback got called. It's going to. We didn't get a ready event either. I wonder if we're actually closing it before we emit the ready event. Because we didn't get one, did we? Oh, we did. Storage backend ready. I put that there. Alright, so these guys. We're not getting this event, so I guess we don't really need this open event. We have a ready event. Don't really need this here. That'll just throw, which I kind of think is better than taking a callback. Because if the store doesn't effectively open, this isn't going to work anyway. So I think throwing here is probably fine. Probably more desirable to throw there than not. Okay. Run a few more of these things. I think this will kind of wrap up this bit. This test has been plaguing me since day one. I guess I just never really took the time to look at it because you can just hit retry and it would usually pass, but kind of like knowing that now it will always pass. And we've solved the test sometimes kind of not working in CI, but more often than not locally the worst. So let's go back to our unit test for the server and change our test count back. 50 will bring us up to 102, right? One for each request, one for each response. The error callback, the error check at the end of the request loop, and an extra pass. So it's 102, and I think that's it. Try this again with all of that happening. This is actually kind of helpful. You can, yeah, it's actually pretty helpful with the little logger thing running on the side. You can see all the events are actually going through successfully with the servers. There's actually, the unit test is actually starting like 3 separate Skyring instances and making sure that when one of them goes down, we still have all of the appropriate timers. So I'm not going to play. Interesting. I'm surprised I've never seen the database not open error before. It seems like it would have happened at least maybe to like 25. That would be 50. You would expect one for each request, which is 25, one for each response, which is 50, the error check at the end of all of the requests, which is 51, plus our close test, 52. I'm going to also, let's double D. I want to use backend out of here. Don't really need to create a database every time test runs, and it should work exactly the same to mem down. This is creating like a database in the temp directory every time. Yeah. Oh, all these oh, well, they'll be gone the next time I restart. That's fine. All right, so let's try and run this guy again with mem down. It should still work the same. Try this again. branch everything. So let's test back here and go check out this payload. Commit message. Fix a flaky unit test. Server test. There was a race between all of the requests being handled and the test server. Fix a couple of things. Test. Take a look at it. Still building. All right. Currently building. And I think we're going to be okay. Should fix that kind of not working all of the time. That's good. That was really bugging me. What else we got in here? All right, I think that's kind of it. That was the thing I wanted to fix. Cool. Oh, that was pretty good. I guess like an hour and a half in. I think I'm going to call it. I fixed the one thing I wanted to fix, and you know, I'll try and do these more frequently. This is my first one, so it's probably a little bit rocky, but you know, we'll get better at it, and more things to come. So stay tuned.